Good afternoon, students.
Good afternoon.
Good afternoon.
Okay, I am fine. I am fine. Do you remember what we have seen in our previous discussion? Do you have remember? Yes. Do you have remember what we have seen in our previous discussion? No. You haven't seen anything? Huh? Who can revise what we have seen in our previous discussion in short way? Okay. In our previous discussion, we have seen uniform motion. Okay, uniform motion. Uniform motion is a motion of a body along a straight line with constant velocity. That means distance is covered equally in equal time interval. Okay, in equal time interval. In our today discussion, we will see uniformly accelerated motion. Okay, uniformly accelerated motion. Before we are going to see uniformly accelerated motion, let us see what is acceleration mean. Acceleration is what? Acceleration is the rate of change in velocity. Okay, the rate of change in velocity. Rate means, for example, rate means something divided by time. Something divided by time. For example, change of velocity divided by time gives for you acceleration. Okay, gives for you acceleration. Therefore, acceleration is equal to change of velocity divided by time. Change of velocity means change of velocity is equal to final velocity minus initial velocity. Okay, where the symbol of delta represents the change. F, for example, is change of velocity. Sorry, this one is change in velocity. Change in velocity, and V final represent final velocity. Okay, final velocity. Final velocity. The VI represented by initial velocity. Initial velocity. So to calculate the velocity acceleration of a body, you must take the difference between final and the initial as change in velocity divided by time taken. Okay, this one is time taken. So by do this one, we can find the acceleration of a body. Therefore, acceleration is the rate of change in velocity. Okay, the rate change in velocity, the change in rate in velocity. From this one, for example, from the given one, you can find final velocity. Final velocity is equal to acceleration times time plus initial velocity, as well as initial velocity is equal to final velocity minus acceleration times time. For example, we do have, in this case, 4 final, initial, time, and the acceleration. So to find one of them, if 3 of them is given for us, we can apply this formula and we can find for the fourth one. Okay, we can find for the fourth one. The other point, the acceleration, uniformly accelerated motion is motion in which velocity of a body changes equally. Have you seen this one? The difference between this one and the uniform motion, equally for equal intervals of time. For example, if the velocity of a body is in 1 second, 2 meters per second, in 2 seconds, 4 meters per second, in 3 seconds, 6 meters per second. This shows uniformly accelerated motion. Okay, uniformly accelerated motion. So if velocity of a body changes equally for equal interval of time, this one shows what? This one shows constant acceleration. Okay, constant acceleration. constant acceleration. Therefore, uniformly accelerated motion means a motion of a body along a straight line with constant acceleration. Okay, with constant acceleration. The other thing what you must know under this subtopic is slope of uniformly accelerated motion. The slope of uniformly accelerated motion, that means B time graph gives for you acceleration. Time graph gives for you acceleration. That means slope is equal to, in uniformly accelerated motion, slope is equal to acceleration. Okay, slope is equal to acceleration. If you calculate the acceleration of uniformly accelerated motion, that acceleration is equal with the slope of v vectors t graph, or the graph of uniformly accelerated motion. It gives for you acceleration of a body or a moving body. Okay, so acceleration and the velocity, acceleration and the slope are equal. Do you remember the slope of uniform motion? What's the slope of uniform motion? What's the slope of uniform motion? Do you remember? Huh? The slope of uniform motion. Yes, one of you? No one? The slope of uniform motion? No one? No one? The slope of uniform motion. What's the slope of uniform motion? Yes? The slope of uniform motion? The slope of uniform motion equal with velocity of the moving body. Okay, velocity of the moving body. You have seen this one in our previous time. Therefore, slope of uniformly accelerated motion gives for you the acceleration of the graph. And the SI unit of acceleration is meter per second square. This means meter times second is a power of -2. Okay, when we bring up this one, it become by negative. So they are equal. Meter per second means, by another way, this one is meter per second. Okay, meter per second. So under acceleration, again, what you must know: when a body starts from rest, it is motion. When a body comes to rest, when a body changes its velocity or decreases its velocity, what will happen? We will see in our next point. Okay. Therefore, for example, if a body starts its motion from rest, its initial velocity is 0. You must know this one again. You must know. If a body starts its motion from rest, its initial velocity is 0. Its initial velocity is 0. And if a body decreases its motion, and if it decreases its velocity, initial velocity become greater than final velocity. Such type of motion gives for you or shows negative acceleration, what we call deceleration. Therefore, under this subtopic, you must know what's the definition of acceleration. One, what acceleration means. Again, what is uniformly accelerated motion? What is the slope of uniformly accelerated motion? Okay, what is the slope of uniformly accelerated motion? You must know. So, depending on this one, we will see examples. Before that, let us see this point. If a body starts from rest, if a body starts this motion from rest, then the initial velocity is equal to 0. That means initial velocity is equal to 0 because of it starts from rest. Okay, it starts from rest. The other point, if a velocity of a body is decreases, final velocity is less than or initial velocity is greater than final velocity. The motion in which final velocity is less than initial velocity, such type of motion is what we call decelerating. Decelerating. Acceleration and the deceleration are different. Okay, acceleration and the deceleration is different. For example, deceleration is a negative acceleration. A negative acceleration. Why? For example, look. For example, acceleration is equal to change in velocity divided by time. Change in velocity divided by time. Let's initial velocity is equal to 16 meter per second, and this is your initial velocity, and your final velocity is equal to 10 meter per second. Okay, and your time may be 3 seconds. Okay, 3 seconds. 3 seconds. If you see this one, it becomes for you negative acceleration. Negative acceleration. For example, look. For example, 10 meter per second minus 16 meter per second divided by 3 seconds. 3 seconds. When you subtract 10 minus 16, 10 minus 16, how many? Yes, 10 minus 16. 10 minus 16, how many you will get?
6. Negative 6.
Negative 6. Negative 6 meter per second.
Negative 6.
Yeah, divide by 3 seconds. Have you seen? Have you seen? Negative 6 divided by 3? Negative 6. Negative 2 meter per what?
Meter per
Meter
second.
Per second or per second square? It is acceleration, okay? Meter per second square. Have you seen? This one shows deceleration, okay? Deceleration. Deceleration, okay? Deceleration. Deceleration means negative acceleration. When initial velocity is greater than final velocity, you will get deceleration, okay? You will get deceleration. For example, look, meter per second square is equal to meter per second square is equal to meter per second per second. Meter per second is the SI unit of velocity. Second is the SI unit of time. Therefore, meter per second times the inverse of this one, 1 over second. 1 times meter, meter. Second times second, second square. Have you seen? This one is the SI unit of what? The SI unit of acceleration, okay? The SI unit of acceleration. So the SI unit of acceleration is meter per second square. Meter per second square from this one. Meter per second square is equal to meter times second is the -2. We have seen this one in our above discussion. The other point you must know under this one, if a body comes to rest, have you seen this one? If a body starts from rest, its initial velocity is what? This initial velocity is what? If a body starts from rest, its initial velocity is 0. Okay, thank you. If a body comes to rest while it is on motion, if it comes to rest, then the final velocity of the body is 0. Have you seen this one? The difference between them? Final velocity is equal to 0, okay? Final velocity is equal to 0. Final velocity is equal to 0. Therefore, you must know this one, okay? You must know. Final velocity is equal to 0 when a body comes to rest. When the body comes to rest. And when a body starts its motion from rest, final initial velocity is equal to 0. If you know these points under acceleration, you can calculate acceleration of the body in as the given question, okay? Depending on the given question, you can calculate the acceleration of the body. But you must understand the points which we have seen in above. For example, what's the definition of acceleration? It is the rate of change of velocity. Change of rate of velocity means final velocity minus initial velocity. You must subtract from final velocity minus initial velocity, divide by time. You must follow this step. And when a body starts its motion from rest, it is initial velocity equal to zero. The other point, you must know what is deceleration means, what we call negative acceleration. And if a body comes to rest, then the final velocity of the body is what? It gives for you negative zero, okay? It gives for you negative. Therefore, if you know this one, you can calculate the acceleration of the body, okay? The acceleration of a given body. Clear? Clear?
Yes.
I think
Yes.
the point which related to acceleration is clear for you. I think it is clear for you. Before we are going to see some calculation or some problems, let us see uniformly accelerated motion by table. Let us see. For example, uniformly accelerated motion is a motion of an object along a straight line with constant increase in its velocity. That means as we have raised up constant acceleration, okay? Constant acceleration. For example, consider the following table which shows uniformly accelerated motion, okay? If you use this one, the table is visible for you, I think, for all of you. Huh? The table is visible or not?
Yes, it's visible.
It is visible. Therefore, look, when the time is zero, speed was zero. And to get the acceleration of the given motion, for example, this table shows us the speed of this body or velocity of this body on a straight line. For example, along a straight line means everywhere speed gives for you along a straight line, it gives for you velocity. Therefore, it increases by in each second, it increases by 4 meters per second. For example, 4 divided by 1, 4. It gives for you 4. 8 divided by 4, 8 divided by 4. 8 divided by 2, sorry. 8 divided by 2, 4. Again, in this case, in this box, the empty on empty space, let us be 12. 12 divided by 3, 4 again. 16 divided by 4, 4. 20 divided by 5, 4. How many we will fill in this blank space? 24. 24 divided by 6,
4.
24 divided by 6, 42. And in this case, 7 and 4 again. Have you seen the acceleration of the given body is constant or not? Have you seen the acceleration? Constant. How many? 4 meters per second square. Sorry, once. Okay, sorry, there is some interruption in this room. So therefore, let us continue, okay? Let us continue. Have you seen the acceleration of the given motion is constant or not constant?
Constant.
Constant.
It is constant.
It's constant.
At any point, if you have seen the acceleration, it gives for you 4 meters per second square, okay? 4 meters per second square. Therefore, this is uniformly one type of uniformly accelerated motion, okay? Uniformly accelerated motion. This motion is uniformly accelerated motion. So we can draw for this table, we can plot a graph of v versus t and acceleration times time. We can plot, okay? We will see this one exploration of graphical representation of uniformly accelerated motion, okay? We will see in that sub content, okay? I think this one is clear for you again. Let us see one example. Let us see one example. The speed of a bus increases uniformly from 10 meters per second to 50 meters per second in 10 seconds. Calculate the acceleration of the body. Have you seen this question? Try this question. The question is visible for you, I think.
Yes.
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 Try this one.
4 meters second.
4 meters per second. That means 4 meters per second square. Huh? It can be. It can be. It can be. Let us see. We will see together. What column? What column? Have you seen students? What is the given one? I think one student said for me 4 meters per second square. Let us see together.
No, I didn't say square.
Okay, let us see.
10 Coramangos.
Ada lagi. 50 meters per second and time. What about your time? What about your time?
10 seconds.
10. Yeah, 10 seconds. 10 seconds. What is required?
Required acceleration.
Acceleration.
How many? Let us see the solution. Acceleration is equal to change in velocity
Final
over time taken.
time.
What is change in velocity? For example, your final velocity was 50
50
meters per
meters per
second
second.
minus
Per second.
10 meters per second.
Minus
10 seconds.
over
Okay.
10 seconds.
over
10 seconds.
second. Yeah. 50 minus 10, 4. 4 meters per second over 10
10
second.
meters per second.
0 cancel by 0. Meter per second means
4 meters per second.
meter per second means only 4 meters per second square. We have seen, for example, under this one, I think we have seen meter per second means meter per second square. Meter per second square. Don't forget. So the SI unit of acceleration is meter per second square 2. Don't forget, okay? For example, you can check from this one for final velocity. For example, from this one, final velocity is equal to final velocity is equal to acceleration times time plus initial velocity, okay? For example, what was your acceleration? 4 meters per second square times your time. What is your time? 10.
10 seconds.
10 seconds. Excellent. 10 seconds plus what was your initial velocity? 10. 10 meters per second. 1 second cancelled by 1 second. 10 times 4. 40 meters per second plus 10 meters per second. Have you seen your final velocity was how many?
50.
50 meters per second. Have you seen? If you check, it is correct, okay? If you check, it is correct. Clear or not? Question number 1 is clear. Or not?
take it back.
Yes.
It's clear.
What you said, another, I have heard another song. I think this one is clear. Let us proceed to question number 2.
Yes.
Question number 2 is visible for you. A car initially at rest accelerated uniformly with an acceleration of 4 meters per second square. What is the speed of the car at the end of 6 seconds? Have you seen? Uniformly means it is on a straight line. What it is, speed means by another way, it is what? It is this velocity, okay? It is velocity. So try to solve this question. So this one is solved by what? First, a car initially at rest, have you seen? It is acceleration is given for you. It is time is given for you. So how we can solve for this question? Try for 2 or 3 minutes. Try. Try for 3 or 2 minutes. Have you tried this question? Have you tried?
Once, Mister.
Try. Oh. Try. Okay, have you tried? Yes? No one? Shall we do together?
Yes.
Yes.
This question is not clear for you? Not clear?
Yes, it's not clear.
Okay. Follow me carefully. Let us do together. A car initially at rest means, what about the initial velocity? What about this initial velocity? 0. Have you seen?
0.
Uniformly accelerated. Acceleration is given for you. Acceleration is given for you. How many? 4 meters per second square. What is another given for you? With what? At
6
the end of
seconds.
Time.
yeah,
Time.
Time is how many?
Seconds.
6 seconds. 6 seconds.
6 seconds.
What is required is from this question is final velocity. Have you seen? Have you seen? Final velocity. Let us solve.
Current velocity.
Final
0.7.
velocity.
0.7.
Are you sure?
No.
Let us do together. Let us do together. Final velocity. What is the formula of final velocity? What is the formula of final velocity? Huh?
Acceleration.
Acceleration
Plus
times time. Time plus
acceleration times time plus velocity final. I mean initial.
Initial velocity. Okay. Look, what was your acceleration is 4 meters per second square.
Second square.
Times, what is your time? 6
6 seconds.
6
6
seconds.
seconds.
plus, what about your initial?
6 seconds.
Initial,
Zero.
initial velocity, 0.
Initial 0.
Yeah, 1 second cancelled by 1 second. 4 times 6, 4
24.
times 6,
24.
24
24.
meter per second.
4.
How do you see? How do you see? Your final velocity is 24 meter per
24
second. Okay?
meter per second.
Yeah, therefore you must know if one says it comes to rest, from rest and etc, you must know such type of equation or such type of problem. You must know, okay? You must know. It depends the way you are you solve the problem is depending on the question given for you. The question given for you. Question number 2 is clear for you.
Yes,
It is quite.
Yes.
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 Let us see next question. Next question. A moving body accelerates from 50 meters per second to rest in 5 seconds. Find its acceleration. A moving body accelerates from 5 meters per second to rest in 5 seconds. Find this acceleration. Find it. Find.
$75
3 meter per second square.
75 meters per second square. Okay,
No,
thank
3.
you. We will see together. We will see together. What
3
about
meter
others?
square.
Yes?
3 meter per
3 meter
second.
per second.
Per second square. Okay, let us see. What about others?
3 meter per
Let us
second.
see. Okay, look, this one I hope when we calculate this acceleration, we will get negative acceleration. Okay, we will get negative acceleration. I hope. For example, given for us, initial velocity is 15 meter per second. Comes to rest. While it is accelerated by 15 meter per second, it comes to rest. From 50 meters per second to rest means comes to rest, okay? Therefore, your final velocity is what? 0. What about your time? It is 5.
5 seconds.
5 seconds.
Negative 3 meter. Negative 3 meter per second square.
Yeah, it can be. It can be. So, look, acceleration is equal to final minus initial over time taken. Your final is 0 already. 0 minus 15 meter per second divided by
Over 5.
5 seconds. 5 seconds. Therefore,
Negative 15 over
negative 15 meter per second divided by
5 seconds.
5. Divide by 5 second. When you divide negative 15 by 5, what you will get?
Negative 3 meter per second
Negative
square.
3 meter per second square. The acceleration of this body is negative 3 meter per second square, which shows deceleration, okay? Which shows deceleration. Therefore, the acceleration of this body or the given equation is deceleration, which implies or negative 3, okay? Negative 3. Do you have any question on these points?
No.
Okay, thank you. I will stop on this point. So in our today topic, you must know definition of acceleration, definition of uniformly accelerated motion, the phrases which concerns with acceleration. For example, from rest comes to rest, decreases its velocity, it is SI unit. You must know this one. If you understand this one correctly, you can calculate a problem which related to acceleration of a body, okay? Acceleration of a body. I will stop on this point. Goodbye for now. See you next time, okay? See you next time. Yes. Yes. Who said
I have a
this?
question.
What type of question? Yes, continue your question. Huh? You said I have question. Continue. What type of question? No one? So we will stop on this point. Goodbye.